looking at? Is this something that you have seen before? Does it bring back some memories? Does it bring back bad memories? Good memories? Just memories. Okay? What are we looking at? Coordinate plane. Okay, our x and y axis. We are going to spend most of the semester talking about this right here. One of the major differences between 131 and 144 is we are going to look at the visual representation of pretty much everything that we do in this class. Okay, so when I talk about a line, we're going to look at the visual representation of a line. When I talk about a parabola, we're going to look at what a parabola looks like on a graph. When I talk about an x-intercept, we're going to identify where that x-intercept is exactly on that graph. So before we can hit that headstrong, head on, we've got to make sure we understand how the coordinate system works. You may hear this called the x and y axis. You may hear this called a Cartesian plane. You may hear this called a coordinate system. Any others? Any others that you've heard of? I think that's pretty much it. Okay? So here we've got our x-axis. Our x-axis is our horizontal axis. Our x-axis is our horizontal axis. Our y-axis is our vertical. Okay? X-axis goes left to right. Our y-axis goes up and down. Okay? This point right here at 0, 0, that is where my x-axis and my y-axis meet. That is called the origin. Feel free to take a picture of this. I know that different professors have different rules about taking pictures. I am a take a picture kind of person. And every time I encourage you to take a picture, I will also say, your brain remembers things you write down. Okay? So you take a picture in case you don't get everything written down, that you can go back and refer to it. But actually taking the notes is helpful for your brain, because as we write it, that is a kinesthetic activity to help us remember it. Okay. So we've got our origin. We've got an ordered pair. That's probably the most important take-home, is how to read ordered pairs. So if I am looking at my x-axis, if I go to the right on my x-axis, those are positive numbers. At the end of this arrow, that's positive infinity. Okay? So all of these numbers are positive numbers, and it goes to positive infinity. You can also go all the way to the left, and you're going to hit negative infinity. So if I have a positive x value, I'm going to go to the right. If I have a negative x value, I'm going to go to the left. Okay? My y-axis, if I go up, that's my positive. If I go down, that's my negative. So when I look at my ordered pair, I deal with my x value first. That means I go left to right first. Then I go up and down. Now, sometimes at this point, when we review ordered pairs, students will say, what happened to rise over run? Alicia, I remember rise over run. I had to go up and down first before I went left to right. What is rise over run? Slope. Okay? It's slope. That is different than what we're talking about right now. What we're talking about right now are ordered pairs. In our ordered pairs, we always deal with our x value first, then we deal with our y value. Okay? Now, our quadrant 1, we deal a lot with quadrant 1. And any time that you are talking about values in kind of the real world, okay? If you're doing a real world application, if you're looking at sales, if you're looking at production, a lot of our real world applications and our word problems only deal with quadrant 1. And you may not realize that anytime you look at a graph on CNN or the Weather Channel or anything like that, you're looking at a coordinate plane. You're just only looking at the positive values. Okay? So quadrant 1, we deal with a lot. Okay? So this is the positive and the positive. Okay? Quadrant 2, quadrant 3, and way? Can you tell me which quadrant the ordered pair is in? I just want you to kind of be aware, because you've probably heard it before. Quadrant might be something that comes up at another time. Okay? Kind of remember? Sort of remember? Okay, we're going to do lots and lots of stuff on our X and Y axis this semester. Can I move off this screen? Anybody need a picture before I do? Okay. So, what we're going to do first, before we do anything else, is we're going to plot some points. Now remember, the first value that you come to is your X coordinate. The second value you come to is your Y. So I am going to give you 1 minute to plot these points. Points. So, for my first one, -1 is my X value, 2 is my Y value. So I moved over to the left, -1. Then I moved up, +2. For B, I went to the right 3, and then I went up 4 because they were both positive. C is my origin, right at 0, 0. D is 3, 0. Now, if I were to say to you, what quadrant is point B in? Could you tell me what quadrant B is in?
1.
Yes, it's in quadrant 1. Now, quadrant C is not in a quadrant, or I'm sorry, point C is not in a quadrant at all. It's at the origin, so it's not in a quadrant. D is on the x-axis. Okay? D is on the x-axis. The 3 means I moved over 3. The 0 means I didn't go up and down at all. So if I said, what quadrant is point D in, the correct answer is it's not in a quadrant. It's on the x-axis. You could say it's in between quadrant 1 and quadrant 4, but it's not in an actual quadrant. Now, those are not conversations that we have to have. They're not problems that you're going to see, but I do want you to be aware of that that's how that works. Okay? E is 2 negative values. 2 negative values. We have -2 and -3. I want you to realize that when we do have a negative x value and a negative y value, this is where our point ends up. It's point E when we have 2 negative values. So I go to the left 2 because of my -2, and I go down 3 because of my -3. Typically, as soon as I remind you about your x and your y's, your right, left, up, down, students do fine with this. Okay, now we're going to do it the opposite direction. I'm going to give you 1 minute, and you are going to identify these points. A, B, C, D, and E. You are going to identify those points. I'm going to turn the lights out. Well, maybe not. Oh, fabulous. There we go. Just for this problem, it just makes it a little bit easier to see. This is the only example that really you've got to count spots like this. Okay? There we go. Okay. Couple things. A is on the x-axis, so I go over -6 and I don't go up and down at all. I want you to look at E. E is on the y-axis, so I don't go up and down at all. I don't go left to right at all. I go down. So notice where your 0 is. For A, my 0 is where my y value is. For E, when I am on the y-axis, 0 is where my x value would be. Okay, so those are y-intercepts and x-intercepts are going to be some important things that we talk about. My B, I go to the left 3, so that's -3, and I go up 5. C is 1, -1. D is +3, +5. Okay? Any questions on that? We doing okay with that? Okay, we are going to talk about 3 formulas today. The first one that we talk about is midpoint. So over here in blue, I've got midpoint, distance, and circle. Those are 3 formulas that you need to have written down before you leave today. Midpoint, distance, and circle. Midpoint is probably the easiest. Distance is probably the most difficult. You do not have to have these memorized. When you take a test, I will give you those formulas. Okay? You do not have to have them memorized. When you take a test, I will give you those formulas. So, this is the midpoint formula right here. And what we are doing when we are talking about the midpoint formula is we are looking at the line segment that is connected by those 2 points. So the points that I am dealing with right now are -5, -3. So I am over -5 and I am down -3. And +9, +3. So I am over 9 and I am up 3. Okay? If I connect those 2 points, I make a line segment. Midpoint formula is probably something that you discussed in high school geometry. The midpoint formula. Okay? Now, the way that we find the midpoint is we add our x values together and divide by 2. Then we add our y values together and divide by 2. These are my x values right here, -5 and +9. We're going to add those 2 together. -3 and +3 are my y values. I'm going to add those 2 together. On your homework, you are going to get to remember how to do fractions. Okay? So you can moan. It's okay. It doesn't hurt my feelings. Okay? But just kind of be prepared for that. When you're dealing with your homework, you're going to get to review how to add and subtract fractions. Please do not turn those fractions into decimals. Leave them as fractions and do the work as fractions. If you're like, hey, Alicia, I forgot how to add and subtract fractions, shoot me an email. I'll send you a video. It'll all be good. Okay? So, what we're going to do first is we are going to add our x values together. So, here is an x value, and here is an x value. So I have -5 plus 9. I'm going to divide by 2. Then I am going to have -3 plus 3, and I'm going to divide by 2. What's -5 plus 9? 4. What's 4 divided by 2? 2. What's negative 3 plus 3? What's 0 divided by 2? Good. So, if I connect these two, there is my midpoint. Okay? And what that means is this distance or line segment right here is equal to this one. Okay? And I know that tick mark is a geometry symbol, but that's what that means. That this distance right here is equal to this distance right here. Okay? That is the midpoint formula. You add your x's together and divide by 2. You add your y's together and divide by 2. Okay? Okay. The distance formula is our next formula. And it is a very, very close cousin to the Pythagorean theorem. A very, very close cousin to the Pythagorean theorem. Okay? Now remember, you are going to have your formula. But understanding where our formula comes from makes a huge difference in knowing how to use it. The Pythagorean theorem is about triangles. The Pythagorean theorem is about triangles. So what I have right here is I have 2 points, negative 2, 1, and 3, 4. So here is negative 2, 1, and here is 3, 4. What the distance formula does is it creates a triangle. Okay? So what I'm going to do is I'm going to find the difference between my two x values. And when I do that, I have created a horizontal distance A. When I subtract the values of my x coordinates, I have created my A distance. Then when I subtract my y values, I have created my B distance. What is a squared plus b squared equal to in the Pythagorean theorem? C squared. So I've created a triangle. So if you can't remember what you're doing when you're using the distance formula, understanding that you're really using the Pythagorean theorem is helpful because that's what we're doing. Okay? So look at my distance formula. Right here, I have the distance between my x values, and then I'm squaring it. So that's a squared. Then I'm taking the distance between my y values, that's b, and I'm squaring it. Now, instead of having it equal to c squared, what have I done? I've taken the square root of that. Okay? That's where that square root comes from. And when we think about it from that perspective, a lot of times it's helpful for us to realize what it is we're doing right there. Okay? So, here we go. I am going to start here. Okay? I am going to start with 3, 4. That's going to be my x sub 2. It doesn't matter which one of those points I start with. What matters is that whichever one I start with for x, I also start with for y. And that's going to be crazy important as we move through all of this. Making sure that whatever point we start with for x, that we also start with it for y. And if you remember back to slope, that was always important. So I'm going to start with 3. So I am going to have 3 minus negative 2. And then I am going to square that. And I am going to add that to 4 minus 1. And I am going to square that. Okay? So I got my 3 and my negative 2 from these values right here. I got my 4 and my 1 from these values right here. Notice my formula is subtraction. What happens to my minus and my negative?
It turns to positive.
Turns to positive. Okay, so that actually becomes 3 plus 2. So that is going to be 5 squared. What is 4 minus 1? Okay. 5 squared is 25. 3 squared is 9. Now, in my last class, I said, now since you can't use calculators in this class, and no one said anything, they were like, wait, Alicia, you said we could use calculators in this class. Okay? So you can use calculators in this class. But we aren't going to simplify the square root of 34 any further. Because if we took the square root of 34, we would get a non-terminating decimal. And that means that our answer is an estimate. So we are going to leave it as the square root of 34. That's just a really good habit to get into, is leaving it exact, because the square root of 34 is exact. Now, this is also an area where students forget. They forget how to simplify radicals. If I have the square root of 34, okay, is there a perfect square I can pull out of that? Okay? Somebody said 4. 4 times what will give me 34? Nothing. Yeah, and it doesn't work. And that's okay. That's how we figure these out. The only thing this breaks down to is 2 and 17. 2 times 17 is 34. That's it. Okay? So this can't be simplified any further. Now, let's just say I had the square root of 32. Okay? Instead of the square root of 34, I had the square root of 32. Okay? The square root of 32 does break down to 16 times 2. What's the square root of 16? 4. Okay? So this is the simplified version. This is already simplified. We cannot do anything else with it. Okay? This is one of the things in 144 that we forget. And that's another thing that I'll hit in chapter 3, is we have forgotten how to simplify radicals. Okay? So be aware of that. Keep that on your radar. That I've got to see if what's inside this will break down any. Okay? Okay. So my final answer for this, and what that means is the distance of C is the square root of 34. Okay? That is Pythagoras. The Pythagorean theorem, which relates to the distance formula. Okay. Those things kind of come back a little bit. Yeah. Okay. So we've talked about plotting points, which is going to be very, very important throughout the entire course. Plotting points. We also talked about the midpoint formula. We talked about identifying points on the Cartesian plane. We're going to move into now determining if points are on a specific equation, if a point makes that equation true. We've done this before for lines, but we're going to expand that to things that are not lines. So the first thing that we're going to do is says check each ordered pair to determine if it lies on the graph. So what I want to know is if I graphed y equals 10x minus 7, if I put that on a graph, would the point 2, 13 be on that graph? That's what I want to know. Then I want to know, would the point -1, -3 be on the graph of that line? That's what I want to know. Now we could graph it, but we also want to look at it from an algebraic perspective. So what we are going to do here is we are going to plug x and y into equation and see if we get a true statement. Okay. If we get a true statement, that means that point is on the graph. That's what a true statement means. If we get a false statement, that doesn't mean you've done anything wrong. It just means that that point is not on that graph. Okay? So I'm going to do the first one. I've got 2. I'm going to plug that in for x, and I'm going to plug 13 in for y. So I have 13 equals 10 times 2 minus 7. Okay? 10 times 2 is 20. What is 20 minus 7? 13. Okay. Because I got a true statement, that means that this point right here is on that graph. That's what that means. Okay? The point 213 is on that graph. So I'm going to write, yes, the point 213 is on that graph. Now I'm going to do the same thing with -1 and -3. I'm going to have -3, because that's my y value, equals 10 times -1 minus 7. Okay? What is 10 times -1? -10. What's -10 minus 7? Good. Okay? Is that a true statement? No. So what that means is this point, if we graphed y equals 10x minus 7, that point, -1, -3, would not be on that graph. That is algebraic of what's happening there. Okay? Now, we are kind of used to doing that with lines. We've done it before with lines. X squared plus y squared equals 16 is a circle. And we're going to talk a lot about a circle in a few minutes. But I'm just telling you, x squared plus y squared equals 16 is a circle. It's a pretty basic circle. The center is at the origin. I want to know if my point 0, 4 is on that graph. So I'm going to plug 0 in for x. I'm going to have 0 squared. 4 squared equals 16. 0 squared is 0. 4 squared is 16. Is it on the graph? Yes. Okay, so 0, 4 is on the graph of that circle. X squared plus y squared equals 16. Okay, for the next one, I've got 2 squared plus 2 squared equals 16. Order of operations means I have to do the 2 squared first. So I've got 4 plus 4. Is that true? No. So that means this is not on the graph. Okay? Can I go on? Okay. Another thing that we do a lot of in this class is we look at tables of values. Graphing using a table of value is not the most efficient way to graph, but it does give us an idea of what's happening when we graph. Okay? It gives us an idea of what we're graphing. This particular equation, y equals x squared minus 2, is a parabola. It's not a line. It's a parabola. That means that it's going to be a U-shaped. X squared minus 2 is a quadratic. The difference between a quadratic and something linear is that this is raised to the second power. Cubic is raised to the third, quartic raised to the fourth. We spend an entire chapter on all that. Okay, we're just kind of doing some overviews. So we're going to determine what this graph looks like using a table of values. So I am going to pick any x values that I want. There are infinitely many points on every graph that we deal with in this class. So we can pick anything for x, anything at all. These are good and safe. -2, -1, 0, 1, and 2. So when you're working on your homework, these are fine values to pick. -2, -1, 0, 1, and 2. Now, what we're going to do is for each one of these, we're going to plug that in for x. So the first one, I'm going to have -2 squared minus 2. So I have taken that x value that I have picked, and I have plugged it in for x. Now, because we can use calculators in this class, this right here is dangerous. If you typed -2 squared into your calculator exactly the way that I have it written, does anyone know what your calculator would tell you? It would what? It would give me -4. Okay? It would give me a -4. Because I have not told my calculator to square the negative and the 2. If I put it in my calculator, like what looks like this right here, I have only told my calculator to square the 2. And then you're going to come back to me and you're going to say, Alicia, my calculator said blah, 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 blah. Now, I've got a 16-year-old boy that tries to tell me stuff like that all the time. And I'll say the same thing to you that I say to him. Your calculator only does what you tell it to do. Your calculator only does what you tell it to do. And if you type in -2 squared minus 2, you have told your calculator to only square the 2. So what you've got to put in your calculator is -2 in parentheses squared. That right there has told your calculator you are squaring the negative and you are squaring the 2. That's what you told your calculator. So let's talk about keystrokes. So on your calculator, you're going to do you're going to do parentheses, -2, close the parentheses. You probably have a button that says x squared. It probably looks similar to that. Okay? Another button that you will use as we move into other functions is the caret top. So you're going to have -2 in parentheses, caret top 2. Using the caret top allows you to raise it to the second power, the third power, and different things like that. Some calculators, instead of the caret top, will have y to the x. Okay? And as we move into that, we'll talk a lot more about that. Okay? The point here is that you've got to put that parentheses around the -2. Then your final step is going to be your -2. So, -2 squared is what? 4. What's 4 minus 2? 2. So my y value here is +2. That makes my ordered pair -2, 2. The same thing is true with that -1. You've got to tell your calculator to square the negative and the 1. -1 squared is +1. And +1 minus 2 is good. Okay, so our ordered pair is -1, -1. When I do 0 squared minus 2, I should end up with -2. 1 squared minus 2, it's going to give me -1. 2 squared minus 2 is going to give me +2. Okay, and we're talking about a parabola, so you should kind of see a pattern with the 2, -1, -2, -1, 2. Okay? If I were to plot these points, so I'm plotting these points right here. That's what I'm doing next. I have -2, +2. I have -1, -1. 0, -2. Oh, that should be +1. This is +1, -2, and 2, 2. Okay? And we have a parabola. And we are going to draw a very smooth line, or a smooth curve. And it should not be going back in like that. It's smooth. So there's my parabola. Okay? So what I have done, and there's lots of different ways to graph a parabola. Well, not lots, but enough. What I have done here is I have graphed the parabola using a table of values. And again, in Chapter 2, we're going to explore quadratics and cubics and quartics and rational functions and all sorts of things. Okay? But right now, we're just looking at one way that we can graph this. And this is graphing it using a table of values. Again, when you're graphing using a table of values, I would like for you to use 0, because 0 is always helpful. Then do a couple of negatives and a couple of positives. If you use these 5 values, you'll be in good shape when you're graphing something like that. Okay. Questions on graphing using a table of values? Graphing on using a table of values. What we are going to do next is we're going to talk about the x and the y intercepts. We're going to talk about x and y intercepts. It's always easier to think about the x and the y intercepts from the graph. Okay? So we are going to look at this parabola, and we are going to identify the x and the y intercepts. First, we need to know what the x and the y intercepts are. What's the definition of the x and the y intercept? I'm going to start with y-intercept because we are familiar with that because of y equals mx plus b. So when I say to you, what is the y-intercept? What can you tell me?
Y equals mx plus b.
Okay, and it's the b part of y equals mx plus b. I heard something up here.
Oh, it's just where on the graph is the y-axis.
That's exactly right. Okay, so y-intercept is where the graph crosses the y-axis. Where graph crosses the y-axis. And when we did lines, we were always concerned about where the graph crossed the y-axis. That's how we graphed a line. We identified the b, we put the plot there, and then we dealt with the points, or the slope. What I want you to understand is we deal with a y-intercept in every kind of graph that we look at. Okay? So having a y-intercept is not something that's just for lines. It deals with anything. So here is our y-intercept. Right here. Now, the thing that you need to know, and this right here is also our y-intercept. What is my x value when I'm dealing with my y-intercept? 0. Okay? When my graph crosses the y-axis, my x value is 0. Okay? Now, these are x-intercepts. We do not discuss x-intercepts as much with lines. We talk about them, but we don't talk about them nearly as much as we talk about the y-intercept because of y equals mx plus b. X-intercepts are where the graph crosses the x-axis. Okay? For this particular problem, we can't identify it very clearly because we're talking about a parabola and it occurs between 1 and 2 and probably -1 and -2. If we were dealing with this particular problem right here, we'd have to use the quadratic formula. We could use simply the square, or we could use the square root property. That's how we would have to solve this. So we're not going to get a nice, pretty, rational answer for this. But I want us to look at it on the graph, because when we do the next one, we'll be able to see it pretty clearly. If I listed what the x-intercept was, my y value would be 0. Okay? So when I am dealing with an x-intercept, my y value is 0. Okay? And we're going to start with a line because we've done x and y intercepts on a line before. Okay, can I go to the next screen? Okay. So here's my line, 2x plus 6, y equals 2x plus 6. I want to find my x and my y-intercept. So I'm going to find my y-intercept first. So I'm going to find my y-intercept first. So what I do to find my y-intercept is I am going to plug 0 in for x. Okay? That's what I'm going to do. I'm going to plug 0 in for x. So I'm going to have y equals 2 times 0 plus 6. 2 times 0 is 0. Okay? So 0, 6 is my y-intercept. And there's the point right there. 0, 6. To find my x-intercept, I plug 0 in for y. So I'm going to have 0 equals 2x plus 6. I subtract 6 from both sides. And I end up with -3 equals x. So my ordered pair is -3, 0. Now, and so let me go ahead and do that. -3, 0. Woo! You guys didn't tell me I messed up. It's okay to tell me I messed up. Were you scared that? It's okay. 0, 6 is positive, so it should have been above the x-axis. Okay, -3, 0 goes right here. So here's my line. Okay? So, that's my y-intercept. This is my x-intercept. Now, if you put this as your answer for y-intercept, I'm good with that. If I say, what's the y-intercept? And you tell me y equals 6, I'm good. If I say, what's the y-intercept? And you tell me 0 equals 6, I'm good. X-intercept, -3 equals x, or -3, 0. That's good. What happens all the time, is the student, when I say find the x and y intercepts, they'll say, okay, the x and y intercepts are -3, 6. Okay, that right there is wrong. -3, 6 is not even on this graph. -3, 6 is -3 up there. It's not on the graph at all. Do not write x and y intercepts in this way, because -3, 6 is an ordered pair that's nowhere near my x or my y intercepts. Be careful. That happens all the time. It happens all the time. Okay? Okay. Now we're going to do something that's not linear. We're going to do one that's not linear. And I want you to look at the graph of it first. Okay, can I move off the screen? Okay. So, if I were to graph this, okay, this is a cubic function, and it looks something like this. This is definitely not exact, but this is what it looks like. Okay? And I'm not asking you to graph it. I just want you to get a visual representation of what it is I'm looking at here. Okay? Where does this cross my y-axis? At 0, 0. How many times does it cross the x-axis? 3 times. Sometimes we forget about that 0, 0, but it is. It's crossing the x-axis 3 times. It's crossing at -2, at 0, and at +2. So it crosses 3 times. So, we are going to find it algebraically exactly the same way we did when we were talking about something linear. So, to find my y-intercept, I am going to plug 0 in for x. So I'm going to have y equals 0 to the third minus 4 times 0. 0 to the third is 0. 4 times 0 is 0. So my y-intercept is 0, or the ordered pair is 0, 0. Okay? My x-intercept, we have to reach a little further into our algebraic toolbox. I'm going to plug 0 in for y. Then I'm left with x to the third minus 4x. And again, we are going to spend an entire chapter on this. But I want you to get some visuals of what we're doing for this course. In order to find my x-intercepts, I've got to solve that. And to solve it, I've got to factor it. You will hear the term solutions for x-intercepts all the time. Okay? You will hear the term solutions. Find the solutions to this function. And when you're finding the solutions to a function, you're finding where that function crosses the x-axis. So, we're going to factor this. What comes out of both of those terms? X. X is my GCF. So I've got x squared minus 4. X squared minus 4 is a special product. It's the difference of perfect squares. And that factors to x plus 2, x minus 2. Now I set each one of those factors equal to 0. And I solve. So I end up with x equals 0, x equals -2, and x equals +2. So I've got 0, 0, -2, 0, and +2, 0. Okay? So that is how x-intercepts and y-intercepts are important, because they help us to give us information about the graph. And you are going to be doing an entire project at the end of the semester that culminates all that information. And you're going to identify x-axes and y-axes and multiplicities and all sorts of stuff. So just know that factoring is very foundational for Chapter 3. And this is just kind of a picture. It's a very, very small picture. Now, one of the things I encourage students to do in this class is to download the app Desmos. Okay? The app is called Desmos. D-E-S-M-O-S. It is a free app, and it gives you these visual representations so that you can is happening with your graph while you're also doing an algebraic process with the function or with the equation. Okay? Questions on x and y intercepts and how they can be applied to things that are not linear. Okay. The next thing that we're going to talk about is symmetry. And we have 3 different types of symmetry. And the graphs that I have written on the board are important. The graphs that are written on the board are not going to show up in the video. So I definitely would take a picture of what's going on the board up here. And I definitely would take time to jot this down. We are going to talk about 3 different kinds of symmetry. Symmetry across the x-axis, symmetry across the y-axis, and symmetry across the origin. Now, if you think about a butterfly, and we think about a butterfly being symmetrical, if we took that butterfly and we folded it in half, what happens? The wings are identical. Okay? In theory, that's what's just happened. Our wings are identical. That is what's happening when we're talking about symmetry across the x-axis, symmetry across the y-axis, and symmetry across the origin. The thing is we fold different things. And it is much, much easier to understand symmetry when we're talking about what the graph looks like than it is to understand symmetry when we're talking about how to do it algebraically. Now, the requirement of you is that you do it algebraically. That's what you're going to do on your homework, is you're going to determine if things are symmetrical algebraically. But before we do them algebraically, I want us to look at them graphically so that we can fully understand what symmetry is. So, this is where Desmos comes into play and where Desmos is helpful, because then you can put it in the graph and you can visually see if something's symmetrical. So, let's look at these 3 different examples right here. This right here is a parabola, but your x is not squared in this one, your y is squared. And that's different. That's not something that we see because it's not a function. Okay? But that's what this is. This is a parabola where y is squared. What I want you to recognize about symmetry across the x-axis is if we folded our paper on the x-axis, then it would be symmetrical. So we are folding here. That's what makes it symmetrical across the x-axis. I want you to look at this value right here. I've got 1, 3. The point that it lines up with when I fold it is 1, -3. Okay? So I have replaced my y value right here with the opposite of y. My x value stays the same. My y values are opposite. That's what makes something symmetrical across the x-axis, is you replace y with the opposite of y. Okay? Now, to determine if something is symmetrical across the y-axis, that means we're going to fold it on the y-axis. Our y values for this one are staying exactly the same, and our x values are opposite. So I replace x with the opposite of x. So here I've got +2. I replace that with -2. So I am able to fold it across the y-axis. Now, something that students assume is that if something's symmetrical across the x-axis and the y-axis, then it's symmetrical across the origin, and that is not true. It's possible, but everything that's symmetrical across both doesn't necessarily have to be symmetrical across the origin. Okay? A circle is, but that's not what we're looking for. Here, I've got something that's symmetrical across the origin. What we do here is we fold it across the x-axis and we fold it across the y-axis. And when we fold it across both, then it's on top of each other. So I have replaced x with -x, and I've replaced y with negative y. Or x is its opposite, and y with its opposite. So here I've got the point 2, 1. When something's symmetrical across the origin, it's negative 2, negative 1. Okay? So you can have something symmetrical across the origin and it not be symmetrical to the x-axis or the y-axis. Okay? They can be completely independent. So, this is what's happening graphically. You definitely want a picture of this. You definitely want to write the graphical stuff down. You may even choose to use Desmos to look at the function or the graph before we ever do anything else with it. So, what we're going to do is we're going to do this algebraically. So, this is what we're looking at right here. Y equals 2x to the third. Y equals 2x to the third. You have to do it and show it algebraically, but looking at the graph is helpful. And we're going to look at the graph afterwards. So, to determine if something is symmetrical across the x-axis, we are going to replace y with negative y and simplify. Okay? So, I am going to look at y equals 2x to the third. And instead of writing down y, I'm going to write down negative y. Now, what number is in front of that y? Negative 1. Okay? So if I divide everything by negative 1, am I back to what y equals? Have I simplified and solved for y? Yes, I have. So I've got y equals negative 2x to the third. Is that exactly the same thing I started with? No. It's not. Y equals 2x to the third is not exactly the same thing as y equals negative 2x to the third. So what that means is this is not symmetrical to the x-axis. So my answer is no, it's not symmetrical to the x-axis. Now, to determine if it's symmetrical to the y-axis, we are going to replace x with negative x and simplify. Okay, we're going to replace x with negative x, and we're going to simplify. So I'm going to have y equals 2. I'm going to put that negative x inside parentheses because then I know I am cubing everything. What's in front of that x? Negative 1. So I am cubing the negative 1, and that's going to be negative 1, and I'm cubing the x. So when I simplify this, I'm left with negative 2x cubed. Is that exactly the same thing that I started with? Negative 2x to the third. Did I start with? No, it's not. So that means it is also not symmetrical to the x-axis. And you can have something that's not symmetrical to any of them. It's possible. You can have just a list of no's, but you've got to show it algebraically, not just graphically. Then for the origin, we are going to replace x with negative x and y with negative y and simplify. Okay? So I'm going to have negative y equals 2 times negative x to the third. 2 times negative x to the third, we end up with negative 2x to the third. Then I've got negative y. What happens when I divide everything? What happens in this situation? I get the same thing I started with. So that means, yes, this is symmetrical to the origin. Okay? And I'm going to move off this screen and show you what it looks like in Desmos. Can I do that now? Show you what it looks like in Desmos?